How do celestial bodies stay afloat in space if space is empty? Space is empty. So, how do celestial bodies stay afloat? You're talking about floating bodies. Where are they floating? They're floating in something, right? So, here's the thing, they aren't really floating. The universe is a stage in which things exist. Energy exists, matter exists, objects exist, massive objects, massive massless objects, particles, all of this exists on this stage. And this stage is a four-dimensional stage called space-time. And all the dynamics of all the objects, the way they move, the way they are situated with respect to each other and so on, all of that is governed by general relativity, and which is gravity. Okay. And inertia. So inertia is Newton's first law of motion. Any object will keep on moving in a straight line, or will either stay at rest or keep moving in a straight line unless it is acted upon by an external force. I think that's roughly how we could say it. So that is the law of inertia, Newton's first law of motion. And then you have general relativity, which is the curvature of space-time. Mass causes space-time to get curved, and the curvature of space-time tells mass how to move. And essentially, this is what is responsible for the various locations and positions and movements and dynamics of celestial objects. So they're not afloat somewhere, floating in the air. They're out there in space-time, essentially. They're out there in space-time. Now, is space empty? That's again another question. Well, space is not really empty. It is bathed in the very faint afterglow of the first light of the universe, the cosmic microwave background radiation, which is just about 2.7 or so degrees above 0 Kelvin, minus 200 something Celsius. You can look up, do the conversion. Okay. So space has this faint afterglow. It is bathed in this faint afterglow, the ancient photons, the first light of in the aftermath of the Big Bang. But then you also have quantum fluctuations all over the place. And that's what quantum field theory tells us, and that has been proven to be true. So you have quantum fluctuations, virtual particle antiparticle pairs being generated and annihilated spontaneously all the time, all over the place. And then you have other things. You have trace amounts of hydrogen gas in space. So it's not entirely empty. It's not quite a perfect vacuum. There's always something or the other in there.